So the way you're most likely going to measure the particle size is using scale drawings because micrometers are not easily available. So what you're going to do is you're going to look down the microscope, and then on your book you're going to draw it exactly as you see it, so to size. So exactly as large as you see it down the microscope is exactly the size you draw it in your book. And so that's a little bit of an error there, but it still works fairly well. So the next thing you're going to do is you're just going to get the ruler, and you're going to physically measure the size of your what you drew. Now you always put the magnification down there, so the microscope, if it's a by 40 lens, there's always the by 10 in the eyepiece lens. It's not just the by 40 objective lens, so it's by 400, so it's always 10 times whatever the lens is. And so the calculation is you just grab that. So I got about 7 millimeters divided by 400, so that's 0.0175, so it's 0.02 millimeters. So that particular particle there in the middle, it goes into the silt category. Now, if you're lucky enough to have a micrometer, this is much faster and much easier. It's just having a little ruler in there. And so this is the by 40 lens, so I know each little increment is 0.025. So I can just look at that and see that it's about 8 increments there, and so I times it out as 0.02, so I get the same answer, but I didn't have to do the drawing. And obviously there's huge errors here. This is just one angle on a 3-dimensional shape, and even if it's in that 2 dimensionals, it's not a circle, so there's longer and shorter parts of this particle, and that's just the one particle. So we won't worry about the numerous errors. I'm just trying to tell you how to work out how to do the size, well, an approximation on the size of one particle.